I'm going to take a couple minutes here to show you how you can use Google Sheets to do binomial probabilities. So the first thing we're going to do is I'm going to look at number 14 on page 194 in your textbook, and again, that's in the PDF file that I uploaded. This is not an assigned problem, which is why we're going to go over it. So we're going to take down some important information here from the problem. A surgical technique is performed on 7 patients. You are told there is a 70% chance of success. Find the probability that surgery is successful for exactly 5 patients, at least 5 patients, and C, less than 5 patients. So we'll put down some important information here. Number 1, N, the number of trials, is 7 patients. Number 2, P, the probability of success, is 70%, so we're going to use 0.7. If the probability of success is 0.7, then Q, the probability of failure, is going to be 0.3. Our X value in this case, since we're doing 7 trials, can be anything from 0 up to 7. So the binomial probability equation can be broken down into 3 parts. So I'm going to create some columns here. First one we're going to create is our X values. And for keep it clean, we're going to center that. So we said our X values can be anything from 0 through 7. So there's all our X values. The second part of our equation, or the first part of our binomial probability equation, is to do a combination of N combination X values. Go right through here, and I'm going to center all of these because we're going to use all of these columns. Sheets has a combination formula for you. We will put in combination, parenthesis, N is 7 trials, and in this case our X values are going to be listed in column A. And we'll hit enter, and it'll give us the solution for 7 trials, choosing 0, and we can drag that down and get all those combinations done at one time. Center those to make it look a little cleaner. So that's the first part of our binomial probability equation. The second part of our binomial probability equation is to do P raised to the X value. Okay? In this problem, our P was 0.7. So here we're going to put in equals 0.7 raised to the, again, X is this cell right here, and we're going to hit enter. And now we're just going to drag that down, and it's going to fill in all of those for us. And if we click on any individual one and look up here, we can see 0.7 to the A7, 0.7 to the A8. So it's automatically adjusted the X values for each of these. Finally, the last part of our binomial equation is Q, the probability of failure, to the N minus X power. So we'll do the same thing here. We're going to type in equals. Our Q value is 0.3 exponent. We're going to do a parenthesis. Our N value is 7 minus X, which again is this cell over here in column A. And it figured out those for us. Drag it down. Last thing, our binomial probabilities are these 3 values multiplied together. And combination X times P to the X value times Q to the and minus x. So here we're going to tell our sheet to do equals this number times this number times this number, and we can drag this all the way down to the bottom. So we've created the entire binomial distribution here in just a few seconds. We've calculated all these probabilities. Now we're going to answer the questions that they ask on this problem. Question A. Question A says, find the probability that exactly 5 patients the surgery is successful for. Probability of 5. Well, that means we just have to go ahead up here and look for 5 successful trials and see what our probability was. Well, here it is, 0.318. So we're just going to put that in here as our answer, 0.318. Letter B asks us, at least 5 patients have successful surgeries. So we're looking for the probability of at least 5 surgeries are successful. Equals. We're going to move over to the next cell to get that answer. Now, when we stop and think about it, at least 5 surgeries are successful means 5 is an acceptable, 6 is an acceptable outcome, and 7 are all acceptable outcomes. So what we're going to do to make this easy on ourselves is we're just going to do a sum of those 1, 2, 3 probabilities. And we get 0.647, which is the correct answer. Okay, I'm going to come over here and put a little note here. We did the sum of, this one would be E11 to E13. So you can see what we did there to arrive at that number. Lastly, less than 5 patients. C wants the probability less than 5. Again, we're going to do a sum to do that. Equals sum, parenthesis. We'll come up here, and less than 5 means 0, 1, 2, 3, or 4. So we're going to highlight those, 0, 1, 2, 3, and 4. And now we've got our correct answer for number 14, 0.353, if you round that off to 3 decimal places. So we did the sum of E6 to E10. And so here we are, we've answered number 14, page 194, very quickly and easily by creating the entire binomial distribution. Now, Sheets has some other functions we can use. Binomial distribution. And in binomial distribution, we need to input our number of successful trials, which is x, our number of trials total, which would be n, our probability of success, and lastly, we need to tell it whether we want to calculate an individual probability or a sum or a cumulative of probabilities. So if we want to do an individual probability like we did here with letter A, we're going to have to type in the word false. So we're going to jump over here, equals binomial distribution. We're going to put in our number of successes. For letter A, we wanted 5 successes. We still had 7 trials. We still had 0.7 as our probability of success. And because we want an individual probability, we're going to type the word false. And hit enter. Again, 0.3176. Hey, that's the same number. I'm going to highlight this in yellow to match it up with the same answer we got up here. So right next to this, I'm going to type in what we put in. We put in binomial distribution 5, 7, 0.7, false. I'm going to jump down to letter C. And the reason for that is because a binomial distribution, if we want to do a cumulative answer, it will only do a sum starting at 0 until we tell it to stop. So in letter B, where we wanted to add up 5, 6, and 7, binomial distribution won't do that for us. Binomial distribution, what it will do is it'll find the sum of 0, 1, 2, 3, and 4, and then we can subtract that value from 1. So let's go ahead and do that on this one. We'll do part B here. We're going to do a binomial distribution. We're going to do 4 as our x value because we're looking for up to at least 5. So the values we don't want are 0, 1, 2, 3, and 4. So we're going to find out what 4 is, 7 number of trials, 0.7 successes, and now we're going to tell it true. Okay. And what we're actually going to do here is we're going to do 1 minus that value. Okay. So here we have it written out. So you can see what we're going to do. We're going to do the exact same thing over here, but we're going to put an equal sign in front of it. So let's try it. Equals 1 minus binomial distribution, 4 total number of successes, 7 trials, 0.7 probability of success, and the word true, meaning we want it to do a cumulative probability. 0.0647, 0695, the same answer we got here. So when we did this, we did the sum of 0, 1, 2, 3, and 4, and then we subtracted that from 1, or 100%. Down here at the bottom, less than 5, that's a little bit easier because we can do that by just doing binomial distribution. So we're going to do binomial distribution. We want less than 5, so we want 0, 1, 2, 3, and 4. We actually already did that up above. 4, 7, 0.7, true. We do want it to find the sum. All right, that's what we're going to do with an equal sign now. Binomial distribution 4, 7, 0.7, true. Did we get the same answer here and here? Yes, we did. So there's a couple of ways there that you can do these. Again, finding exact values, I think it's very, very easy to do the entire chart. The Sheets is doing the hard work for you. You're really only inputting the first row and then dragging down from the corners to fill in the rest of the chart. Just be careful that you input your data correct. Remember, I'll put a little note here. This is to put in combination n, x. And once you've done this, you can answer any of the questions right from there just by finding individual cells for exact answers or using the sum function to find ranges of answers. One of the other questions that can be asked is find the probability of, let's say, between, let's go with 2 and 6. 2 and 6 inclusive, meaning we're going to include 2 and 6 in the answer. Now, it's a little more difficult to use the binomial distribution function here. It can be done. You'd have to do 2 calculations and subtract them. So if we want the binomial between 2 and 6 inclusive, meaning we're looking for those 4 values, or those 1, 2, 3, 4, 5 values added up, it's very easy to do that if we've created this whole chart, because we can just do the sum and highlight those 5 values. And it will give us our answer. And again, we did a sum of E8 to E12. And that's one way you can do it. The other way you can do it is to calculate a cumulative sum of 0 and 1, and a cumulative sum of 0 through 6, and then subtract those values. So we can do a binomial distribution 6, 7, 0.7, true, because we want it to do a sum, minus a binomial distribution of 2 successes, incorrect, 1 success, we want the 2 to be included, 7 trials, 0.7 for your P, probability of success, true. And I'm just going to go ahead and copy all of that so I don't have to retype it. Come over here and put equals and paste that and hit enter. And look, we got the same 0.9138549 here and here. So we know we got the correct answer. So there's lots of ways you can do this in Google Sheets. There's also ways you can do it in a TI-84 if you have one. I'm not going to do a video on that because there's lots of videos on YouTube already for how to do these in a TI-84. But those of you who don't have a TI-84 at home, you can certainly do all these different probabilities in Google Sheets. And I learned how to do this about 10 minutes ago for the first time, so I think you guys can look it up and figure it out. If you have any questions, there's always the Q&A doc. Take a look at that, and I hope this helps.